Hello, and welcome to Lab Day. We are going to do the density lab. We are going to determine the density of a couple metals and a liquid, and we're going to use that information to determine the identity of some unknown samples. The first metal that we're going to explore is aluminum. And right here, I have an aluminum cylinder. And I do happen to have it on a little fishing string so that I can lower it gently into a graduated cylinder, which is here. Here's our graduated cylinder. We're going to find volume by displacement. So we're going to use the change in water level to find the volume of whatever we submerge into the water. The cylinders, we could find the volume by calculating using the geometry formula to find the volume of cylinders. But for our purposes, let's work with displacement. So the first thing we want to do is find the mass of our sample, our aluminum cylinder. Now we do have a little bit of fishing string, but that's not going to create any major mass. Oh, before we put our object on the scale though, we should always hit the re-zero button to make sure our scale is properly calibrated. And then we can put the sample on the scale and we can read it. Now, it's a little tough for you folks because it's a little angled, but it is 70.1. That's what it reads. So the aluminum cylinder, 70.1 grams, and you'll see the little G for the units there. We need to find the volume of this cylinder, so what we're going to do is we're going to take some water. Now I did add a little green food coloring, just so it can be a little more visual in the camera. And we're going to fill the graduated cylinder to a certain volume. I overfilled it a little bit. It's a little too full. We always suggest about halfway. And you don't have to get it to an exact number. You can make it any value you really want, but here you can see that I'm pretty close to 50 milliliters. And I have my little pipette here, and so I can add a little extra or remove a little extra depending on my need. And so now I'm looking pretty good. Oh no, wait, no, I'm mistaken. I'm at 55, 56. So actually, see, you always got to double check your measurement. I'm going to take away a little bit of this. Almost there. Bear with me. Got an air bubble there. We got all kinds of problems. Still got an air bubble there. And we need to just, I think, just touch it up just a little bit. I think we can call it 50 right there. Now, what we do, so 50.0 milliliters. So that's 50.0 because we're directly on that 50 line. What we're going to do is we're going to submerge the cylinder, and the cylinder must submerge all the way for this to work. Now if we read that, and I'll bring it a little closer, we are just under or about, a little shaky, sorry. That's very close to 75. Okay, it's a little tough at this angle, but when I bring it a little closer, depending on the angle where we're reading it. So this, we're reading, now you're reading the cylinder, it's up at you're reading it kind of up at an angle, which messes up your sight line a little bit and your reading. But if I bring it down here, and keep it even with the camera, you get a better feel for the reading. And we are very close to 75. So we can call it that. Would be probably good enough. Now I'll remove this and put it off to the side. And your job is going to complete the rest of the information in the lab form to calculate the density of aluminum. I'm going to move on though to the next metal. We have copper, and we're going to mass it. And I'm massing it before I put it in the water because I don't want the mass wet to add extra mass. Re-zero it, and it says 70.2. We're going to double check our water level, and it looks pretty much still at 50, which is good. We didn't lose any with the aluminum really. So we're going to submerge this gently so I don't break the graduated cylinder. And you can see it rose to a little short of 60. It's not quite 60. So yeah, not 60. Between 59 and 58. I'm a little shaky here, sorry. So make a judgment call. Are you going to call that 59? You're going to call that 58? I'm thinking it's a little closer to 59. And so we take that out. So that one's done. Okay? And again, you have to complete the calculations. I'm going to skip to the zinc since I'm doing the solids. Again, re-zero the scale. 68.2 grams. All right. Now, again, let's double check our instrument. Our water is our instrument here, and we're still at 50. I'm a little short, maybe a drop or two, because when I took those other metals out, it took a little bit of the water with it. There we go. So we're at 50 milliliters again, 50.0. And there, oh, we are right under 60, aren't we? So let's get a little closer look at that. I mean, it's not quite 60. It might be like 59.5. It's not 59, it's a little above that. So, you know, here you can, you know, you can guess in between those little lines. So, you know, 60, 59, 59.5. It's a tough call. You're gonna have to make that determination. You can actually look back in the other videos and ask yourself, well, I mean the other videos, the other materials in the video, and say, did you want to make it a whole number? Or did you want to make it maybe a decimal in between the numbers for values? All of your values should have a tenths place. So we start at 50.0, and if you say you go to, you know, say if you went up to the volume earlier of close to 70, well, you don't just put 70, you put 70.0. Or if you thought it was 69, you'd put 69.0. Or if you thought it was in between, maybe you say 69.5. So you're going to rewind the video and alter your readings just a little bit to tune it in just a little bit more. All right. Now, the next scenario, we're going to take the density of a liquid, and we'll need a container to do that. And this is our container. This is a smaller graduated cylinder. It's only 10 milliliter maximum. Again, I'm going to re-zero my scale because I'm going to take the mass of this. Not that we want the mass of the scale in the end, but we want to know the starting mass of the scale. 27.6 grams. Because we're going to add alcohol, ethyl alcohol, in this bottle. And I'm going to add a set amount. Now we have to choose how much we want to add, what volume. And I'm thinking, let's just go max. Let's go all the way to the 10. It's pretty easy to do. Let's look at this. Let's see what the reading is. Did I reach the 10? I'm actually a little over, so let's pour a little bit of this out. Just a little bit. All right. Just a little bit. All right, let's see what this looks like. Okay, we're just about 10 there. Now, you'll see kind of like a curved, kind of shadowy area at the top of the letter, top of the liquid. That's called the meniscus when it kind of has some curvature in it, and you read what we call the bottom of the curve. So the bottom of that curve is definitely on right at that 10 line. And so now that we have 10.0 milliliters, that's going to be our volume of liquid, our volume of alcohol. And when I put this on here, the scale rises. We're now at 35.7 grams. I should have re-zeroed it before I put it on there, but I did look and the scale was still at 0, so I'm confident in it. And so this isn't the mass of a liquid. It's the mass of the liquid and the cylinder. So I want to find just the mass of the liquid. So what I'd have to do is take this mass and compare it to the starting mass of just the cylinder. And how do I deal with that? Well, hopefully you understand and can figure that out. What are you going to do with those two numbers? So now I have enough information to calculate the density of aluminum, copper, zinc, and the ethyl alcohol. And what we're going to do is try to find the density of 3 unknown materials. And so we're going to take a break, and I'll come back with that.